In a historic declaration that may change our position within the cosmos forever, NASA has announced the identification of a signal that seems to be the first extraterrestrial sign coming from the direction of Proxima B, the nearest known exoplanet to Earth. Located approximately 4 light-years away, Proxima B falls within the star's habitable zone, Proxima Centauri. The discovery has enthralled individuals worldwide and kindled huge interest among the scientific community and the general public. It has raised one of the most significant questions human beings have ever posed to themselves. Could this be the day we find out that we are not alone in the universe? This historic progress started with careful observations by some of the most sophisticated telescopes that have ever been built. Scientists have been scrying across far-off stars and star systems for years for indications of life. Amongst these star systems, Proxima B has been one of keen interest because it is close to Earth and shares Earth-like qualities. It has been a top contender in the continuous hunt for extraterrestrial intelligence. The signal that was picked up from its direction is unlike any recorded so far, irrefutably shaped and uniform, devoid of the random nature of natural cosmic events. Should it be confirmed as genuine, the implications could change our conception of life, technology, and our existence in the universe forever. Identification of this signal lends credibility to the age-old hypothesis that Earth is not alone in its ability to sustain life. Scientists have speculated for decades that planets around stars in the habitable zone, places where temperatures would permit liquid water to exist, could contain life. This signal, however, indicates something beyond mere habitability. Its form is suggestive of intention. It may be a beacon or an intentional communication effort. This also brings to mind questions about the presence of life beyond Earth and the nature and development of any civilization that could have launched it. Are they fellow observers such as ourselves, launching communications into space with the hope of connection? Or something else entirely, so much more advanced, perhaps even much more ancient, with motivations that we cannot yet hope to understand? The repetition of the signal in an orderly fashion was noticed right away by scientists. It was remarkable compared to the billions of random, natural radio bursts the universe periodically releases. Scientists from NASA and other global institutions started collaborating with each other to confirm the signal, characterize its features, and eliminate all sources of terrestrial interference. The preliminary findings were convincing. Unlike all previously known natural sources, the signal had no correlation with any artificial satellite, terrestrial device, or known astrophysical event. It consistently repeated on a frequency, with a Doppler shift that matched the anticipated movement of Proxima B against Earth. Although caution has been exercised, excitement has increased as additional layers of analysis have been unable to rule out the signal's legitimacy. Throughout the globe, individuals are having new discussions regarding the universe, about humanity's existence within the universe, and about what life could be like elsewhere. There are those who see intelligent life that may be grappling with very similar questions of purpose, war, and peace. Others see civilizations far more advanced than our own that an attempt to decipher their message might be tantamount to ants figuring out language. The finding has intrigued world leaders, philosophers, religious thinkers, and the general public. There are arguments over how humanity should react if this transmission is a message. Do we respond? Do we wait? Do we share our existence, or keep silent and observe? The ethical and existential issues are immense. Skepticism does have its place in this unfolding drama. History has demonstrated that countless promising signs have ultimately been blamed on earthly interference or misinterpreted natural phenomena. Radio telescopes, regardless of how advanced, inevitably detect false positives, signals that replicate extraterrestrial communication but come from ordinary causes such as faulty electronics or orbital junk. In this instance, however, the criticism has been unusually stringent. The potential for error is being tested and retested using techniques honed through decades of experience. It is this very caution that lends the present results validity. If this signal holds up to all testing, it could be the first time in human history that humanity has overheard a message from another intelligent species. Proxima B's possible message brings to mind earlier episodes in science, like the 1977 discovery of the WOW signal, which initiated decades of speculation. That signal, also, was never attributed to anything, although it was never replicated either. The Proxima B signal, however, has been picked up over a 30-hour window and has shown consistent properties on numerous passes. In contrast to lone anomalies, this signal has been robust under questioning, making scientists go deeper. The signal was detected with the Parkes radio telescope in Australia, as part of the Breakthrough Listen initiative, an ambitious privately funded effort committed to searching for extraterrestrial signals. With thousands of hours of observational data and cutting-edge technology, the Breakthrough Listen project has been a leader in SETI, search for extraterrestrial intelligence, research. Proxima Centauri, the parent star of Proxima B, is a member of a triple star system consisting of Alpha Centauri A and Alpha Centauri B. Both Alpha Centauri A and B are of similar size and temperature to our Sun, whereas Proxima Centauri is a much fainter red dwarf star. The star system has intrigued astronomers for a long time due to its proximity to Earth and the possibility of having planets in the habitable zone. Proxima B, which was discovered in 2016, was discovered by the radial velocity method, which measures the small movements of a star due to the gravitational force of planets in orbit. Its mass is roughly 1.3 times Earth's, and is thought to have a rocky interior, so it is a top contender for Earth-like conditions. The planet, though, is tidally locked and orbits its star at much closer range than Mercury orbits the Sun. However, since Proxima Centauri is cooler and less bright, the planet continues to receive only approximately 60% of the solar radiation Earth receives, plenty enough to be able to harbor life under appropriate conditions. In order to learn more about Proxima B and other potential exoplanets, scientists have looked to the James Webb Space Telescope, the largest and most capable space observatory ever built. Sent to probe deep into the cosmos and investigate the atmospheres of far-off planets, the JWST has transformed exoplanet science. Its capability to examine infrared light enables it to identify significant chemical signatures, including water vapor, methane, carbon dioxide, and ozone, markers of biological activity. By conducting precise spectral analysis, JWST can reveal information on surface temperatures, pressure in the atmosphere, and the possibility of clouds or oceans. It can even spot the faint heat glow of rocky planets around distant stars, putting it among our strongest tools for the search for life. JWST's purpose is not only to study individual worlds but to learn how planetary systems arise and develop. Its mid-infrared cameras have the ability to penetrate deep cosmic dust clouds, catching the initial stages of star and planet formation. It uncovers the fundamental chemistry involved in planetary system birth, chemistry that might be a basis for life. The MIRI instrument, mid-infrared instrument, of the telescope is especially well positioned to do this. It can identify hot molecular gas, such as hydrogen cyanide, water, and carbon-containing molecules, which are seen as key precursors to biological life. By gazing at young stars that are still enveloped in their birth clouds, MIRI provides scientists with clues to the conditions under which Earth-like planets can form. These clues are assisting scientists to link planetary formation with habitability. With JWST ongoing observations, more Earth-like exoplanets are anticipated to be discovered by it, and whether or not the requirements for life are common or not in the galaxy will be determined. Already, thousands of exoplanets have been entered in the inventory. Included among them are an increasing number of super-Earths and mini-Neptunes, planets the size of Earth or Neptune, some of which orbit in the habitable zones of stars. With advancing technology, scientists are now getting to know these worlds in better detail, looking for those which, not only could possibly be habitable, but might be inhabited. The possible signal from Proxima B can be a beacon in this quest, centering attention on targeted objectives that are worth thorough examination. It would prove that not only can we detect planets that are similar to Earth, but that intelligent life can develop and try to initiate communication as well. Such a discovery would mark a fundamental shift in our understanding of biology, evolution, and perhaps even consciousness itself. It would suggest that life is not a fluke or a rare phenomenon, but a natural consequence of the universe's design. As scientists continue their work, humanity finds itself on the edge of a new era. The search for extraterrestrial life is no longer confined to fiction or theory. It is based on facts, technology, and an insatiable curiosity. What was once unfathomable, that we could hear from another civilization in our lifetime, is now something that scientists are seriously preparing to do. Protocols are being debated, response plans drafted, and ethical dilemmas posed about what type of message humanity should send back, and who is entitled to speak for an entire world. We are coming into an era where the universe is not only a painting of stars, but a realm in which we may one day engage in dialogues across light years. With every breakthrough, we inch our way toward knowing not only the universe, but ourselves. Finding a signal on Proxima B, whether ultimately confirmed or not, serves as a reminder of the enormity of potential and of the profound desire within us to connect, explore, and know. As telescopes sweep the heavens and computers sort through seas of information, the question lingers, are we alone? And beyond that, do we really want to know? The road ahead could bring us revelations that upset our presuppositions, our cultures, and our systems of belief. But it is a road worth traveling. Because in that pursuit lies the essence of what it means to be human, to look up, to wonder, and to reach out into the darkness, hoping that someone, somewhere, might reach back.